Hello and welcome to the Learn Competitive Programming with Codechef channel. Today I'm Nishchay Manwani and I'm going to be teaching about how to practically apply dynamic programming in questions. If you are a competitive programmer and have been doing competitive programming for a while, you might have come across many dynamic programming questions because that is the most popular archetype in competitive programming. So you might have wondered, is there a general roadmap that you can use to solve dynamic programming questions? Because all of the dynamic programming questions are lot varied, right? There is bit masking, there is range, and there is linear dynamic programming, there is 3D dynamic programming. So to give a general roadmap on how to conquer these type of dynamic programming, I will be taking this class. There will also be two problem solving sessions on the Unacademy platform. These will be special classes, so they will be free to watch. So you can come at the Unacademy platform tomorrow at 6 p.m. or on the 15th at 6 p.m. These will be the problem solving sessions I will be having. But before that, I will be teaching about how to tackle dynamic programming, right? So a little bit of introduction about myself. I'm Nishchay Manwani. You guys might know me as Zeusors at Codeforces.com or NM at Codechef.com. At Codeforces, I'm currently an international Grandmaster, AI All India rank 2, I think. And Codechef, I am a 7-star, All India rank 12 currently. And recently have joined an academy in their competitive programming goal, right? So my profile is capitally small and capitally small m. You can go to this site to view my profile. Basically what this competitive programming goal of an academy is there will be many courses which you can join, and we will be teaching you these courses. So what you will get in this competitive programming goal of an academy, you will get, first of all, live interactive classes. There will be many classes where you will be asking me doubts, I can answer them, or I will be asking you questions and you can answer them. So all of the classes would be interactive, right? There would also be relevant problems at Codechef, uh, where I have selected these problems to be kept on a certain platform, and you can go and practice these problems on Codechef itself. So after a class, if you have studied a new concept, you can go to Codechef directly and practice on those problem. There will also be a doubt support. Me and many talented teaching assistants on an academy and many talented educators as well. All of them are always available to solve your doubts. There is a Discord platform, Discord server where you can ask your doubts, or there is a Codechef forum as well where you can ask your doubts. You can also ask your doubts in the classes itself. But most of the time, your doubts generally do get created if you're solving problems as yourself, right? So at those times when there is not a current live class going on, you can come to this Discord server or Codechef forum and you can ask your doubts there. So a little bit of introduction about the educators. All of the educators are really strong in competitive programming, right? There are people who have gone to ICPC World Finals. There are people who have won IOA medals. There are people who have high ratings on Codeforces and Codechef, etc. So there are people who have come from big companies like Google, Flipkart, etc. Right? So these are all the educators. Tanuj Khattar, who is a 2 times world finalist. Arjun, who has won an IOI bronze medal in 2015. Murugappan, a software engineer at Google. These are really, like everybody is really strong in competitive programming. One more thing that I want to notify that doubts regarding doubts in this class, I would try to look at the comments regularly. So if you do guys have any doubts, I would be answering them immediately. But like at least I would be answering them in every 20-30 minutes, right? So I do have a doubt. Someone has a doubt right now. Are you going to take the DP course on Unacademy Plus? I'm not taking the dynamic programming course. Dynamic programming course is taken by Arjun P. He's an IOI bronze medalist. So you can go and study dynamic programming from him. I just wanted to take some problem solving sessions because there are some problems, the problems that I'm going to cover tomorrow and on the 15th. These are problems that I really, really liked, and I wanted to share the solution with everyone, right? So I will be discussing on these problems alone. Uh, I'm going to take a computational geometry course, which will be starting on Wednesday. So if you're interested in ICPC or competitive programming, which concerns with geometry parts. So you can come and see that course. Also, there is a course on number theory which I have taken. So and that's also available on Unacademy. It's finished now, but you can still ask me doubts regarding any doubt you have when you see the number theory course. So there is a number theory course you can view right now of me, or there is a computational geometry course which you can follow live as I am teaching on Unacademy, right? So some topics like number theory, which I have taught, will be also be computational geometry. The beginner things will also be going to teach. So if you're a complete beginner, don't know programming at all, you can come here and learn C++ foundation, Java foundation, Python, introduction to programming. Or if you want to get into competitive programming and know a bit about programming before, then you can come and learn about STL, basic data structures, number theory. That is also a beginner's course. uh, Greedy algorithms, dynamic programming, etc. And then there is the advanced stuff. If you have been in competitive programming and know all of this stuff and want to get more ahead in competitive programming, there is segment trees, graphs, advanced dynamic programming, computational geometry, which I'm going to take, right? And there will be miscellaneous ICPC regionals plus world finals problem solving, all of these part, right? So here's it's written upcoming courses, but these courses, most of them are currently running or have been finished, like my course on number theory. Pulkit is taking on graphs, Murugappan is taking on greedy algorithms. So these are all the courses that you will be getting if you join the program. There are also special classes related to each course, so you can go and view those free special classes and try to see for yourself if you like the content or not, right? So there will be a special forum on Codechef as well to ask doubts. As I was talking about, there are many talented teaching assistants on Unacademy as well, so they will be always be there or to ask answer your questions on Codeship platform. And also there is a Discord server made currently, which is, I feel, more interactive way to answer your doubts. So you can also join that Discord server. It's free for all, so you can join that Discord server, and all of the learners of our plus courses can ask doubts there itself, right? So there will also be course-wise practice problems, as I was talking about the relevant problems corresponding to each lecture. So they will be available here at Codechef at this platform, right? So the pricing part is currently like it's 6,000 per month, and for 6 months it's 4,000, and 12 if you select the 12 months part, it's less than 2,500 per month, right? So these are the pricing part, but you can get a 10% discount if you type in the code capital E small n capital E small m. These are the discounted parts, right? So you have to type in the referral code, which is capital E small n capital E small m at the Unacademy subscription part, and you will get 10% discount on your Unacademy subscription, by which you can buy these courses. But first, you can see if you like the course and the content that we provide, right? So there are also many free classes coming on Unacademy, like I have tomorrow on problem solving, right? So this was a short introduction about Unacademy. Again, I'm going to be looking at doubts all of the time, right? Uh, so let me just go to my whiteboard and start talking about how to apply dynamic programming, and start talking about why you should know about this. So this is I've switched to my whiteboard currently, and I'm going to be talking about three things, which are three not basically things, basically three points or main objectives that you have to look forward in a dynamic programming questions. And those three main parts are: there is a overall roadmap in every dynamic programming problem, right? And the roadmap is corresponds of 3 points, which is first is the identification of DP. Basically, you have to figure out if this problem is of dynamic programming or not, right? Many a time you don't know like what kind of concept this problem is using. So first you have to figure out this problem is of dynamic programming, right? Then the next part is logical thinking part of dynamic programming, right? And this would be the main part, and these two parts are closely linked together. Might be, like, basically these two parts can be grouped in a single point as well, but this is the main part that you have to think of, and I will be talking about how there are 3 points within logical thinking part of well within the logical thinking part of DP as well, where you can, look at the roadmap and try to figure out how to apply dynamic programming, right? So let me talk about the last point, which is the implementation part. And this is, if you have done competitive programming for a time, many people can say that this is the easiest part, right? Because most of the time you have to figure out, okay, what states are this used, what recursion formula is used. So this is the main part in recursion in dynamic programming problems, and this you can do at the end, which is kind of simple. I would be also be talking about like two main things which is used in implementation: tabulation and memorization, and the differences between them, right? So this is going to be the overview of today's session. And also I would be discussing all of this with a problem. Just give me a second. uh, just wait a second. So a reminder to all, if there are some off-topic doubts you have, right? There are people who are asking for how to prepare for ICPC and stuff like that. So all these off-topic doubts I will be answering at the end of the lecture, because I want to focus on the topic at hand first. So if you do have these doubts, stick around until the end, and then I will be answering all of the doubts that these kind of doubts, like how to have a roadmap on competitive programming or how to prepare for ICPC and stuff, right? Let me look at the problem. Right. So the problem is, it's rather a very classical problem. Many people might already know the solution of this problem, but that's why I'm going to take this problem, because it will be easier to understand what I am doing, right? With this problem, and easier to understand the roadmap that I'm taking to solve this problem. So the problem is simply, let's say we have two matrices, some A matrix and some B matrix, right? So the A matrix has A11, A12 up until, let's say, it is a matrix of X into Y, right? So this would be AX1, A21, A22. So this would be A1Y, this would be A2Y, this would be AX2, and this would be AXY, right? So this is one matrix, this is the A matrix, right? Let me write that clearly. And then we have the B matrix, which is going to be of the size Y into Z. So basically, the number of columns here is equal to the number of rows here, right? So this is a B11, B12, up until B1Z, B21, B22, up until B2Z. Similarly, here it is going to be BY1. Just give me one more second. BY1, BY2, BYZ, right? So when we multiply two matrices such as these, right? So A into B, what is the product going to be? Let's call it some C, right? First of all, C is going to be of the size X into Z, right? Here Y was common, so the resultant matrix is going to be of the size x into z. And let's say the C matrix is of C11, C12, C1z, C21, C22, C2z, right? And similarly, CX1, CXZ, right? So here, basically, what multiplication means in matrices that Cij, let's say some here, there is some Ci and j, right? What this element is going to be, it's just going to be equal to the ith row here multiplied by the jth column here, which means it is going to be ai1 into b1j, right? Sum ai2 into b2j, summation, etc., 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 up until ai y into b y j. Is this correct? Yes, right? So this is actually the element Cij in my resultant matrix. This is a basic concept which you guys might have known if you have studied matrix multiplication. But if you haven't, this is basically how we do matrix multiplication, where each element such Ci and j is basically the ith row in the first matrix multiplied by the jth column of the second matrix, right? So this is taking y multiplications, right? This is taking y steps basically. Let's call that as y steps. And there are a total of x into z elements which we have to calculate. So the number of calculations that we have here is x into y into z, right? This is the number of steps that we have to take to multiply two matrices here. This is just a revision of matrix multiplication, right? I'm going to go into the problem now, right? This was just the precursor to the problem. The problem is, let's say we have n matrices. So the matrices are A1, A2, A3, up until some an, right? Here the matrix is some a1 into a2, right? Here the matrix is of size a2 into a3. Here the matrix is of size a3 into a4. Basically, each the number of columns in the previous matrix is equal to the number of rows in the next matrix, right? Similarly, we have an into an plus 1 here. So these are the n matrices. We have to multiply all of these matrices together, right? So a1 into a2 into something a2 into a3, that is going to result in some matrix of a1 into a3, right? And then a3 into a3 is going to result in something of a1 into a4, right? So we have to give the resultant matrix here. We have to figure out what is the minimum number of steps required to multiply this, right? Basically, what is the minimum number of steps in which we can do this complete multiplication? This is basically, we want to figure out the optimized algorithm to multiply these n matrices. And to find that optimized algorithm, we have to apply dynamic programming here, right? So let me go into the identification of dynamic programming part. How do we identify that this problem is actually of dynamic programming, right? So before identifying that this problem is of dynamic programming, we have to play around with this problem a little bit. We have to observe some key points in the problem first, right? So in the identification part, also you have to be really good in backtracking to do dynamic programming, right? You have to know how many problems work, how we do the recursion part, how what solutions a problem might have. So a precursor to dynamic programming is obviously backtracking. You have to practice on backtracking first and then jump into dynamic programming, right? So the identification part is basically, let's play around this with this problem. The optimal number of steps of a1 into a2 into a3, etc., up until an, right? is nothing but, I'm going to write the recursion formula here, is nothing but either we can, let's say, we can group these A1 up until AN into some certain parts, right? We can either group like this, right? Where we multiply A1 into A2 into A3 up until AN, right? So we just have to apply brackets here, right? Or we can either do A1 into A2 into, let's say, A2 into A3 up until AN, right? Or we can either do A1 into A2 into A3 into A4 into A5 up until AN, right? We can do either of these things up until, let's say, we have A1 into A2 into A3 up until AN minus 1 into AN, right? We have to apply brackets basically, which of these would be optimal, right? So in here, we can see one property, right? If we, let's say, pick this point, right? Let's say we pick this point. Let's say we are multiplying A1 into A2 into A3 first, finding out the product, which would return here. And we are multiplying all of these matrices, finding out the product, and then multiplying both of the products together to find out the resultant matrix, right? So here, one should note that optimal number of steps in A1 into A2 up until AN is nothing but, let's say, A3, the resultant of A1 into A2 into A3, what is it going to return? It's going to return a matrix of size A1 into A4. We have seen here, right? So basically, A1 into A2 into A3 is going to be a matrix of right? And the remaining matrix A4 into A5 up until AN is going to be a matrix of A4 into AN plus 1, right? So when we multiply these two matrices together, right, the number of steps which are generated more are the number of steps we have seen before, which is x into y into z. Here, x into y into z is nothing but A1 into A4 into AN plus 1, right? So the number of steps here is A1 into A4 into AN plus 1 plus, there is an important plus here, uh, this plus is going to denote the number of steps we required here and the number of steps we required here. And would our total solution, right, would our total number of steps, would it be optimal? Or by optimal, I mean the minimum, right? We have to find the minimum number of steps, right, to multiply all of these matrices. Would our final answer be minimum or optimal if we don't take this to be minimum? Of course not. We have to take the number of steps used in multiplying this to be minimum as well, right? So basically, here the plus part will denote optimal of A1 into A2 into A3 plus optimal of A4 into A5 up until AN. So whatever number of steps required in this matrix multiplication, we have to take the optimal of that, and whatever number of steps we have required in multiplying A1 into A2 into A3, we have to take the optimal of that as well, right? So the optimal, our total answer, uh, the total answer for that to be optimum, we have to take the sub problems here. This is called a sub problem. We have to take that as optimum as well, right? So this is the first property that we have to look forward to in a dynamic programming problem, is optimal substructure property. Maybe I have basically introduced this property a little in a convoluted way and in a complex way. But this is a really simple property. Basically, what it says is that for the final answer to be optimal, for the final answer to be optimal, the subproblems have to be computed optimally. Here, optimally is an important word, right? This property is also observed in greedy problems, right? This is both in greedy and DP, right? So whenever you see this property in a problem where basically there is a huge set and the optimal answer in this set is will be related somewhat to optimal answer of a subproblem, right? Then that means this problem is either a greedy problem or either a dynamic programming problem, right? And the second property, which you guys might have seen here, is overlapping subproblem property. And what overlapping subproblem property means, and this is the most uh, like eye-catching property that you have to look for in dynamic programming. Basically, if a problem depicts overlapping subproblems, it's dynamic programming, right? Mostly, it's just dynamic programming, and nothing else have to be used other than overlapping subproblem property to identify a dynamic programming problem, right? So what overlapping problem property is basically two subproblems can overlap while we are trying to find the optimal answer, right? So basically, in our problem of uh, trying to find the minimum number of steps in that matrix multiplication, here we have A1 into A2 up until AN. To calculate the optimal answer for this, we have to calculate the optimal answer for just A1, right? We have to calculate the optimal answer for A1 into A2 as well. We have to calculate the optimal answer for A1 into A2 into A3. Similarly, we have to calculate the optimal answer up until A1 into A2 up until AN minus 1, right? We have to calculate all of this sub problems. Basically, we have to find out, we have to recursively do the solution for these problems as well, right? And when we are trying to find the A1 into A2 into A3, or let's say A1 into A2 up until, let's say N minus 1, when we break this problem further, we have to find the optimal answers for A1. We have to find the optimal answers of A1 into A2. We have to find the optimal answers for A1 into A2 into A3, right? And what happens here is we have this subproblem and this subproblem to be equal. We also have this subproblem and this subproblem to be equal, right? Similarly here and here. So basically, when we are trying to find out this problem, we can reuse this problem. Basically, I feel this problem is a little complex to make you understand overlapping subproblems. Let me switch to a simpler problem, which you guys might have known, which is Fibonacci. Fibonacci numbers. Fibonacci numbers are basically, let's say we have f0 is equal to 1 and f1 is equal to 1. And then every Fibonacci number, fn, which is here n is greater than or equal to 2, is nothing but fn minus 1 plus fn minus 2, right? So here we have the Fibonacci sequence is called as 1, 1, 2, because 1 plus 1 is 2, right? 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. So this is the Fibonacci sequence, right? So if you have to calculate, let's say some fn, what you will do, you will basically generate a function int f of int n, and then you will return f n minus 1 plus f n minus 2. Also have some terminating cases n is equal to 1 or n equal to 0, just return 1, right? Basically, it would be a function like this, where you are recursively trying to find the Fibonacci numbers. Here, if we try to draw the tree of the recursion calls, right? So we have to find some Fn. In here, we will have two recursion calls. We have to find Fn minus 1 and Fn minus 2. In here, when we are trying to find Fn minus 1, we have to find Fn minus 2 and Fn minus 3. So here as well, you can see there is an overlapping sub problem. We have to find the Fn minus 2 two times, right? We have to find that here and here as well. And when we expand Fn minus 2, we find out that we have to find Fn minus 3 as well. Right? In here, we have to find Fn minus 3. So we have to find actually Fn minus 3 times. So why not store that and use that whenever this problem comes again? That is basically the essence of dynamic programming, where we have to store the past sub problems that we have and use them in the next problem that we are going to have. So this is called overlapping sub problems. This is a sub problem where we have to find the Fibonacci of n minus 2, and the sub problems are overlapping here, right? So let me look for any doubts if you guys do have any doubts here, and then we'll go to the logical thinking part and the implementation part. Right. So let me go. This is how to identify, like any dynamic programming problem. You have to look at basically two properties, which is overlapping subproblem and optimal substructure property, right? Now let us go to the massive part, that is the logical thinking part. The logical thinking part. And I'm going to break this into 3 steps, so you can have a basically a roadmap on how to apply dynamic programming, right? And how to tackle any problem, which is first is the identification of states, right? And what when I say states, I want to say that you can have any state, right? Like if in the problem above, which I was talking about, matrix multiplication, you can have a state which includes all of the numbers, right? A1, A2, A3. It includes up until an. This is one state. This is going to store how many numbers? It's going to store A1, A2, A3, up until an plus 1. So it's this state is going to store n plus 1 numbers, or rather this state is going to be represented by n plus 1 numbers, right? And what do I mean by state? A state is basically a sub problem or a problem, right, which we are trying to solve. So we are trying to solve this optimal of a1 into a2 into a3 up until an, right? And it will have n plus 1 numbers. So we are going to be representing the state by n plus 1 numbers, right? But this would take a massive overhead, because we do not want to store n plus 1 numbers just to represent one state. What we're instead going to do, we want to store as little as low dimensions as we can, basically dimensions, or basically as low number of states as we can to represent a state, right? So in here, what I'm instead going to do, I'm going to represent a state such that we have as we have the number of states as low as possible, right? And basically in this problem, when we are trying to solve the optimal answer for matrix multiplication of a1 into a2 into up until an, what is a possible state that will, represent the whole problem. We do not want a state that will not represent the whole problem. I cannot choose a state, let's say I, right? It doesn't represent the whole problem, and it's not going to include all of the sub problems that's going to have, right? So it cannot be a linear DP here, right, where I'm just trying to solve a3 into a4 up until an, because it's going to be using a3 into a4, right? So here a state is going to be a set of two numbers, which is L and R, right? So these two numbers are going to be representing a state. And what these L and R means, these represent a sub problem. These represent a sub problem, which is trying to find the optimal of AL into AL plus 1 up until AR. So this sub problem which I have of trying to find the optimal property, optimal answer of this range, I'm going to be storing that by these two numbers, which is L and R. L can be from 0 up until N, right? And R can be anything from basically L is less than equal to R is less than equal to N. And here 0 is less than equal to L is less than equal to N, right? So here we are going to have N square states, right? Because L can go from 1 to N, sorry, this should be 1, from 1 to N, and R can go from L to N. So we can have N square states here, right? Or N square by 2, whatever you want to say. Basically, we are going to have big O of N square states, right? Uh, so this is how we try to find out the states. Basically, we have to try to find out the state such that it represents the whole problem. It represents the whole sub problem. There shouldn't be any information missing. Here, when we take two numbers, we aren't missing any information, right? Because we can pick the numbers, which is AL, which I have to pick, like AL plus 1 up until AR plus 1. We can figure out these numbers if we have L and L and L and R, right? So we aren't compromising on any information, and this variables can represent the problem as a whole, right? So AL up until AR, this can represent the problem as a whole, and we should be using this sub problem in our final answer, right? Also, we have to figure out what the state is going to be holding, right? In my case, this state is going to be holding the minimum number of steps required to multiply all of these matrices, right? The second step, after finding out the the how to represent the states, like how to identify the states, the second step is trying to find a base case, base states, right? Trying to find out the base states we have, or base cases. That is a much more common word, right? Base cases. So basically, base cases means the cases or the states in which the answer is going to be direct. We have to calculate those the answer of those states first, right? So in here, in our problem, the base cases are going to be any L is equal to R, right? These are the base states, and what would be the answer be in that case? 0, right? The answer is going to be 0, and the state is going to be L is equal to R. Why this? Because if we have some L is equal to R, then basically what that means, we are trying to find the optimal or the minimum number of steps required to multiply AL, just one matrix, right? And we don't require any number of multiplications to find the product of just one number. It's going to be of one matrix. It's going to be the matrix itself, right? So here we have answer is equal to 0. You could have also chosen the base states to be something like R is equal to L plus 1. You could have chosen this, right? It's up to you. You can choose the base case however you want. And in here, it's going to be something like we are trying to find the optimal number of multiplications of AL into AL plus 1, right? Here, the size of this matrix is AL into AL plus 1, and the size of this matrix is AL plus 1 into AL plus 2, right? So the answer here is going to be AL into AL plus 1 into AL plus 2. Basically because of the X into Y into Z property that I talked about before, right? So this is going to be the answer of this range. You could have chosen the base case to be this, but just because of personal preference, I try to choose the base cases as primitive as I can, right? So I don't have to think much about the base cases itself. So I would just choose L is equal to R as a base case and put the answer to be 0, right? So the optimal of AL is just going to be 0. Then comes the final and the most important part of any dynamic programming problem, which I have been kind of steering away from for this problem, which is the recursion formula. You have to do all of these three steps together, right? You have to identify the steps, the states. To identify the states, one could argue that you require the recursion formula first to identify the states, and that is true. One could also argue that you require the states first to identify the recursion formula. That is true as well, right? So you kind of have to do all of these three steps at the same time, but you have to think about these three steps that you have trying to find the you're trying to find the states. The base cases is just a trivial step. You can also forget that step. Basically you are trying to find the states and the recursion formula. These two things you have to find out for any dynamic programming problem. And in here the recursion formula is going to be, let's say I denote optimal of AL into up until AR as dp L comma R, right? So basically what recursion formula means, it's trying to calculate what this dplr is going to be, right? So it's going to be basically 0 if L is equal to R, right? That is the base case that I have included. Otherwise, it's going to be, let's say I try to break up some AL into AL plus 1 up until some AR, right? I try to make this at some AI into AI plus 1. So basically I put a bracket here and a bracket here, right? So I would have to calculate the optimal number of steps required here. I would have to calculate the optimal number of steps required here. And then I would have to multiply these two matrices. And whatever the number of steps I do get in that multiplication, I would have to sum that in both of the optimal number of steps that I get, right? So here, it's going to be minimum of this, right? I can choose I however I want from L up until R. So I would have to go at each I and try to find out at which I'm getting the minimum number of steps, right? So in here, the basically let me write that down. Else, it is going to be minimum of I is equal to L up until R. I is equal to R. Let me write that in a proper way. I is equal to R, right? Minimum of I is equal to L up until I is equal to R. Optimal of uh, optimal of AL up until AI, or I can write that as dp L comma I plus dp I plus 1 comma R plus the multiplication part, how I'm going to multiply these two matrices, right? So that is going to be A. Actually, I should be up until R minus 1, right? I wouldn't want to be there to be an infinite loop. So I'm just going to be including I up until R minus 1. And here it's going to be A L into AI plus 1 into AR, right? How do I get this number? It's basically the size of this matrix is AL into AI plus 1, and the size of this matrix is going to be AI plus 1 into AR. So when I multiply two matrices of these sizes, I get the number of steps that I require as AL into AI plus 1 into AR. Right? So this is the recursion formula that I need, which is I is equal to L from I is equal to L up until I is equal to R minus 1. The minimum of this value, which is dpli, which is the optimal of the left part, dpi plus 1 comma r, which is the optimal of the right part, plus the number of steps I require to merge these two parts, right? So whatever the minimum of this is, it's going to be my dplr. And this is the recursion formula that you have to think for the problem, right? Let me see if there are any doubts. Excuse me. Next time is asking why I'm teaching a standard question on dynamic programming, right? Because that this dynamic programming problem is easy to explain. I would be going on to some complex problems or the problems that I found interesting in the problem solving sessions, right? That's why I have taken these problem solving sessions. But I felt that this problem is really kind of standard and important to teach how to have a roadmap on dynamic programming. That's why I took this problem as an example. Bakshi asks, I have spoiled many DB questions. There are infinitely many, not infinitely many, but there are so many dynamic programming problems that you can spoil dynamic programming problems for yourselves, right? Don't think of like looking at an editorial as spoiling the problem for yourselves. That is, many people have that mentality. It's not good because there are really many problems that you can, work at afterwards. So you have to look at editorials continuously to understand the how to do these problems the next time it comes in a contest, right? I tried only for 1 hour. I sometimes only try for 5 minutes, right? It's really not uh, something that you should be ashamed of or spoiling the problems for yourself. Uh, Let me go on. This is the complete logical thinking part. So we have looked about 3 points in logical thinking parts, which is first trying to find the states. Second part is trying to find the base states. And the third part is trying to find the recursion formula. The recursion formula is the most important part. That is closely linked to trying to find the number of states, right? So after you have done this, after you have found out the recursion formula, after you have found out the number of states, you might want to try to analyze the complexity. What the complexity does this have? So as to look at, is this going to work, right? Always try to find out the complexity of your code before coding itself, right? Before implementing the question, you have to look at the complexity that your logic has. So let's look at both of the complexities, which is the time complexity first. So any dynamic programming problem is going to have a time complexity of, let's look at the space complexity first, right? I think that's much more easier to explain, right? So this is going to be uh, the number of states itself, because we are storing some values, right? In dynamic programming, which is the essence of dynamic programming is storing the values of sub problems. So we are storing the values of how many number of states there are. So the number of states into memory used in each state. This is the complete space complexity, right? And the memory used in each state, like in our case, the memory used in each state is just big of 1, because we're just storing the answer that this state is going to have. We're just storing the minimum number of steps this state is going to have. So here it's big of 1. Many dynamic programming problems have memory used in each state as big of 1. So basically it boils down to the space complexity being equal to the number of states. However, the time complexity, in time complexity, we have to, we have to find out the answer for each state, right? and the answer of each state is going to be found out by the recursion formula. So here the time complexity is number of states into the time utilized in recursion formula. Right? Let's look at the dynamic programming problem that we had, where we have to multiply n matrices, right? So here the time complexity, we have number of states n square, and we have time utilized in recursion formula as n, because we are iterating. Basically, let me go a little up, right? We're iterating from I is equal to L up until I is equal to R minus 1 and trying to find the minimum of all of these values, right? So here we have big of n square into big of n. So this is the time complexity, which is big of n cube. And the space complexity is just the number of states, and memory used in each state is big of 1. So here the space complexity is big of n square. And then look at the constraints. In this question, I haven't given the constraints, but try to look at the constraints and see, okay, so if I have n is equal to 100, then n cube is going to work. But if I had n is equal to 1000, then n cube isn't going to work. Then I have to find a better dynamic programming solution, right? Where basically the main kind of, you can guess that the recursion formula is not taking that much time, or the number of states are less, right? So you have to switch your method and try to find another solution, right? So we have figured out right now that right now we are at the step that we have figured out that these constraints are going to be working. Let's say n is less than equal to 100. So this is going to be working, right? Then we have to figure out the implementation part. And implementation is going to be easy. Basically, we are going to be declaring a 2D array denoting the dynamic programming part and storing the values in that 2D array, right? But there are two basically important choices. Basically, there is one choice that you have to take when trying to implement a dynamic programming problem, is whether you use memoization or you choose tabulation, right? So as to explain what these methods are and what are the differences between these methods, let's jump into the code editor and try to implement this problem, right? And I will be explaining what these two methods are as I code, right? Let me look at the doubts first. Couldn't understand the merging part. The merging part is basically, let me go back to the merging. Let me write, yeah, here's the merging part, right? Basically, this matrix where AL is of some size, let's say AL into AL plus 1, and AL plus 1 is of some size AL plus 1 into AL plus 2, right? If we multiply these two matrices, the number of steps required is AL into AL plus 1 into AL plus 2. These are the number of steps required to multiply these two matrices, right? I have talked about this in the beginning of the class, but basically, if you know about matrix multiplication, you can understand that why these many number of steps are required, right? So this whole matrix, which is AL into AL plus 1 into up until AI, is going to be of size AL into AI plus 1, right? Because this is of size AI into AI plus 1. And when we keep combining these matrices, the final matrix size is going to be returned of AL into AI plus 1. And if we keep combining these matrices, the final size is going to be AI plus 1 into AR, right? And when we multiply these two matrices, the number of steps that are coming extra is AL into AI plus 1 into AR. AL into AI plus 1 into AR, right? So this is the extra number of steps that we require to kind of merge these two products together, to multiply these two matrices, right? To multiply these two matrices, we require this many extra steps, and that is the merge step here, right? Uh, how should we extract recursion solution from the DP solution? That comes from experience. As I've told you before, you should study, you should look at many recursion formulas, many backtracking problems first, right? And also look at many dynamic programming problems. Dynamic programming is a typeset where generally it's it is much more helpful to practice than to study, right? So you have to practice a lot and look at lots of editorials to kind of get perfect in trying to extract the recursion formula and the identification of states. So you have to practice to figure that out. Can you right? So let me go into the implementation. Let me switch to my code editor. And if you do have some doubts, I will be looking at them after the implementing this, right? So do not worry about that. So this is my code editor, currently in light theme. So let me take in the problem first, right? I have some n matrices, which I will be taking as int n. I will be coding in C++, but you can basically understand what I'm trying to do, even if you do not know C++, right? I'm going to be coding very simply, right? So I take all of the integers that I want to take. There will be n+1 integers, right? So I will be taking all of these integers in my input C in AI. And basically what this means is, let's say some matrix, or the ith matrix is of size AI into AI plus 1, right? The ith matrix is of size AI into AI plus 1. This is what this signifies, right? Let us go forward to how do we implement that. So to implement this problem, as I said, I have to include n square states. So I'm going to be initiating a integer of dp n, right? This signifies the n square states that I'm going to have, right? I'm going to be storing the value of those states in this array, right? And also I'm going to be storing -1 in all of the states before. And what does this -1 signify? This -1 signifies that the DP array is not calculated correctly, that this DPIJ is not calculated. Because we don't know, when we try to look at DPLR, we don't currently know that if it is calculated or not calculated. Can we use this in our algorithm or not, right? So I'm going to be initializing all of the DPIJ as -1, which will denote that this is not calculated currently, right? Then what I'm going to do, I'm just going to call a recursive function, right? So let me uh, output the total answer, which is going to be from 0 up until n. And I'm also going to be giving the initial array I have, right? So in here, let me initialize an answer function. It is going to be containing two numbers, int L and int R, where I'm trying to find the answer of L up until R, right? And I have some array A, right, which denotes the sizes of the matrices. So in here, I'm just going to be including the base case and the recursion formula. If L is equal to R, then we have to return 0, right? That was the base case. Else, what we have to do, let's initialize an answer, right? Int answer is equal to, let's say something big, right? Let's say 1E9. This is our current answer, right? And then I would go from int I is equal to L, I is less than R, and I plus plus, I would go all of these steps and try to minimize my answer, right? So in here, answer is equal to minimum of answer, comma, the recursion formula which I said was dpli plus not dp, sorry, answer of l comma I comma a plus answer I plus 1 comma r comma a plus a l star a I plus 1 star a r, right? And finally we just have to return answer. So you might have seen I haven't used dynamic programming here, right? Where is the dynamic programming part or the implementation that I was talking about? In here I haven't used dynamic programming, but basically I want to show that if this question came and n was something really less, let's say n was 5 or n was 10, then basically you could have used this function, and the answer would have been correct, and there wouldn't be any like any overhead on time complexity or dynamic program memory complexity, right? Here basically it is a backtracking solution. Here I have used backtracking to find the answer, right? Basically I'm going from l up until r, l comma I comma a I plus 1 r comma a. Basically I have done a recursive solution to find the answer, right? And this is a backtracking solution. To upgrade this to a dynamic programming solution, to update my constraints for this function to be working on only up until n up to 10, to be working on n up until 100, right? I have to include the dp uh, uh, array as well, and instead of including that in the function itself, I'm going to be declaring dp outside. Let's call it dp 105,105, right? This will be a global variable, right? Initially I have declared all of them as -1 as not calculated, and here if dplr is not equal to -1, that means dplr must have been calculated before, right? dplr is not equal to -1, that means dplr must have been calculated before, and I'm just going to be returning dplr, and this is going to be my answer, right? Otherwise we are going to calculate dplr, and I'm going to set dplr as answer, and then I'm going to return the answer, right? So to upgrade from a backtracking solution to a dynamic programming solution, it's really easy. You just have to include a storage case, and use that storage case to return the answer directly if it's already calculated. And if it is not calculated already, right, in the else case, I'm going to be calculating that answer, setting the answer to be used in further calculations, and just returning an, right? So this is how I upgrade the backtracking solution to a dynamic programming solution. This is called memoization. When you directly upgrade a backtracking solution and a recursive function to a dynamic programming solution, it is called memoization. Basically, I'm using this array, this 2D array, this global variable as a memo, as a way of storage, and just utilizing that in my backtracking solution, right? So this is called memoization. Memoization means using a recursive function to calculate the answer, right? Here, it is comparatively easier. It's easier to code because you do not have to think much about the implementation. You just have to write a recursive function and just include a way of storage, right? This is comparatively easier to code, but it has more, not time complexity, but it takes more time to compute, right? Because it is a recursive function, and if you know, recursive functions are more time consuming than iterative functions, right? So recursive function here, it is going to take much more time rather than just like calling a recursive function, iterative function, right? So memoization is comparatively slower but easier to code, right? Now I'm going to be showing you tabulation, how to do tabulation. And basically what I do in tabulation is I'm trying to calculate dpij in my code itself, in the main function itself, right? So what I'm going to do, for int I equal to 0, I is less than n I plus plus, I'm going to be initializing dpi I is equal to 0 for all. And then I'm going to be starting from a distance of 1, right? So distance is equal to 1, and distance is less than n, distance plus plus. What this distance function means, basically, for int I equal to 0, I is less than n I plus plus, dp I and I plus distance. I'm trying to calculate dpi and I plus distance, right? This, let's say, is something 1e9 currently. And then I'm going to call the recursion formula here as well for int j equal to some I, j is less than I plus distance, j plus plus, dp I plus distance is equal to minimum of dp I plus distance, comma, dp I j plus dp j I plus distance plus a I star a j plus 1 star a I plus distance, right? So this is the recursion formula. This is the base case. And these are the number of states, right? This is the state identification. This is the base case. And this is the recursion formula. This is called tabulation. Here, what the important part is I'm doing the distance part first. And here as well, I'm going to be calling n minus distance, right? So as I plus distance is not greater than equal to n, right? Here, the important part to note here is when I'm trying to calculate dpi and I plus distance, I'm using dpij and dpj I plus distance. And here, both ij and j I plus dis are less than the current distance that I'm trying to calculate. So j minus I, let me write that here, j minus I is less than distance, and I plus distance minus j is less than distance, right? What this means is basically I have already computed dpij and dpj I plus dis when I'm trying to calculate dpi I plus dis, because I'm going iterating from dis 1 to n. That's why I've already calculated these states before going to this state. So this is called tabulation. Smartly thinking about which state I have to calculate it, first, and then calculate that state first, and then use that state to calculate the next state. What would the final answer here be? It is just going to be cout dp 0n, right? This is tabulation. It's comparatively faster because it's just iterative and put in the main function itself, right? So it's going to be faster because it's not calling a recursive function. But it's a little difficult to understand and a little difficult to code, because you have to think which states are going to be calculated first and which states are going to be calculated later. So you have to figure that out and always ensure that the states that are going to be using this state, if a state is going to be using this state, then this state has to be calculated before than this state, right? So you have to think about that process and then write an iterative code to find out the dynamic programming states and finally just output the state that you want, right? So this was tabulation, comparatively faster but harder to code. Comparatively, we have memorization, which is easier to code but takes a little more time. The time complexity of both is going to be same, big of n cube, but just there might be a difference of 0.1 second or a 0.3 second, right? Not much time difference, but it's still going to be 2 times or 3 times, right? So let me look at some doubts. If you do guys do have any doubts in this, just let me know. How much time to give for a DP problem? You can give how much time you want. It's not exactly for a DP problem. For any problem, you have to think about the problem unless you cannot think anything else, right? basically up until the point where I literally cannot proceed in this question further. I cannot think anything else. That might be for some problems just 5 minutes, or for some problems might be days. You have to think for that problem up until then, up until your mind is developing to, you know, get new concepts in your mind. If you cannot think anything else, just go to the editorial. If I have a time crunch, then go to the editorials instantly, right? Then if you do have a time crunch, uh, basically if you're trying to prepare for interviews and it's in 1 month or 2 months and you're going through the problems, then I would recommend to, keep a time limit. Basically keep a 1 hour time limit. You can go to the editorials before that as well. If you cannot think anything else, go to the editorial in 5 minutes. But if you do have a time crunch, then keep a time limit, like let's say 1 hour or 2 hour, and then go to the time editorial. uh, but in a contest, I would give at least 20 or 30 minutes before giving up and trying other questions. That is sorry, that's Aman is a teaching assistant in chat, so you can ask your doubts to him as well. Right. So these are all the doubts currently. So this was all about dynamic programming, right? Using these concepts, I have talked about first the identification of a dynamic programming problem. I have talked about overlapping sub problems and optimal substructure property there. Then I have talked about the roadmap to think about a dynamic programming problem. There you have to think about what states you are going to use, what would be the base cases, and what is going to be the recursion formula. Then I have talked about like you have to think about the complexity that a code has first. Then you have to go about implementing that, and you have to choose whether to go to tabulation if you think you can do tabulation code easily and it's not going to take much time for you, or you should go to memorization because you think coding this would be hard and you don't want to put more time, put more thinking in how to code it, right? You just want to code it right now, so you have to choose between tabulation and memorization. Then uh, these are all the steps that you require in a dynamic programming problem. Tomorrow I'm going to be taking a session on problems solving, 6 p.m. on Unacademy platform. It is going to be free, so you can tune in. I will be taking problems on dynamic programming in probability or game theory. I have these two problem solving sessions, right? Also, there is a feedback form in the description of this video. So please do go to the description and fill that feedback form. It helps me to understand if I'm going too fast, if I'm going too slow, or in which areas I have to improve, or if you like the session overall. So please do fill that feedback form. And if you like this video, give a like or subscribe to this channel, of course. And I would be also, if you do have any doubts after this class which you want to ask me, right? If you do have any doubts that you want to ask me personally, or you want to ask about how to prepare for interviews or how to have a general roadmap on CP, right? You can ask me on my handles, which is NM on Codeforces, or NM on Codechef, or Source on Codeforces. Let me show my handles here, right? You can go to these handles and message me there, so I can respond to your queries after this class. Let me look at the doubts once more, right? And then I will be ending this class, right? Please don't private this video like one of the Pulkit sirs. All right. And is there any question list for DP questions if you can provide? You can go to Codechef and sort by tags there. There's a nice feature on Codechef where you can sort by tags and it would provide you all of the questions. Let's say you sort by tag on number theory, it would provide you all of the questions on number theory. If you sort by tag on dynamic programming, it would provide you all of the problems on dynamic programming. Then you can sort by the number of successful submissions, and it would give you the questions which have the most number of successful submissions, and it will also give you the questions which have the least number of successful submissions, right? For someone who has started CP journey, should I do DP questions along the way? Yes, absolutely. DP questions are really varied because they can be of really easy difficulty as well, and there can be really, really hard DP questions as well. So you should start doing DP questions and try to find easy questions and solve them. Uh, DP problem links, again, the Codechef tag sort by tags, or there is a add code DP contest as well. You can go there. I really like that contest, so you can try to solve problems there. Uh, right, and if like advice on INI or ICPC, you can again ask me on these handles, which is users at Codeforces or NM and Codechef. Right now it's 7:13. So again, please fill the feedback form in the description, right? And due to in my next class, which is going to be in an academy, and I will be closing this stream right now. All right, bye, see you tomorrow.